In this video, we're going to be working the Algebra 2 5.3 quiz, which is all about factoring. So we're going to factor all of these things completely, really starting by looking for a greatest common factor, and then hitting with our various factoring techniques that we've learned. So I'm looking at these things, I'm saying, is there anything common to both of them, right? I'm seeing 2x to the 3 and 32x. I feel like maybe 2x is common to both of them, and I probably won't do this every time, but I'll write this as 2x times x squared, the first term, and negative 32x as maybe negative 2x times 16. And then I can factor out the 2x, and I'd be left with x squared minus 16. And then I see that x squared minus 16 is a difference of two squares, and I know I can factor that with x plus 4 times x minus 4. Right now, so each time I use one of these rules for the first time, I'll flash it up on screen, but if in case you need to copy it down, which would be the best way to learn it, but past that, I'm just going to kind of use the rules. All right, a to the 3 minus 27. Okay, so I'm saying that this is a difference of two cubes, right? This is a to the 3 minus 3 to the 3. Okay, so the rule is a to the 3 minus b to the 3 equals a minus b. So a minus 3 multiplied by a squared positive plus a times b, so a times 3 is 3a, plus b squared would be 9. And there we go. I had something else to say about this. Oh yeah, the second thing, this will never be factorable, so I know I'm done from here. Alright, t squared minus 2t minus 24. This is an old-fashioned quadratic, right? We studied these in the last unit, we studied these in previous courses. We're looking for two numbers that multiply to negative 24 while adding to negative 2. So I'm thinking 6 and 4 somehow, so maybe negative 6 and positive 4, yeah. So I've got t minus 6 multiplied by t plus 4. I can stop and double check that, kind of like mentally distribute and see what's going to come back, and that's going to work for me. Alright, this next one's got 4 terms, so I'm thinking group and factors. So I look at the first two, and what's common to y to the 3 and negative 10y to the 2. Just 2 powers of y. So I've got y squared times y minus 10. And then negative 4y plus 40. Okay, 40 is divisible by 4. It doesn't have a y in it, so I'm thinking the 4, but maybe I should factor out a negative 4 so that I can get that y minus 10. So that's the whole idea of group and factor is, get it so I can factor out a binomial. And it's like, oh yeah, okay, this is going to be a difference of two squares, and I can keep going. And that'll be it for that. Alright, 8x to the 3 plus 1. This is looking like a sum of two cubes. So maybe I'll go over here and I'll say, oh yeah, 8x to the 3. That's what I would get if I cubed 2x. Oh, oops, having problems here. Okay, and we need the sum of two cubes rule. Alright, so remember SOAP, right? Look at this sign, the same, opposite, always positive. Okay, oh, whoops. Uh-oh, that's not good. Pardon me. A squared minus AB plus B squared, yeah. Okay, so it's going to be A plus B, so 2x plus 1. A squared, I'm going to square 2x, so that would be 2x times 2x is 4 times x squared. A times b is 2x times 1, so minus 2x and plus 1 squared. And that's as far as I can go. And over here we're looking for a greatest common factor, and I think I see it. Yeah, we can factor out an x. So I factor out that x, and I'm left with 3x squared plus 7x plus 2. And then this is a quadratic, so oftentimes these can be factored. And I look at it, and I say to myself, all right, I'm going to take 3 and 2, and I'm going to multiply them together, and that's going to equal 6. And so we're looking for two numbers that multiply to equal 6 while adding to equal 7. That's going to be 6 and 1. And so you can take that 7x and you can split it into 6x plus 1x, or you can split it into 1x plus 6x, but we've done this a bunch in this class. So I've got x times 3x squared plus 6x plus 1 more x plus 2. And then I'm going to do group and factor. Okay, there's nothing to factor here, so I'm going to factor out a 1, so I've got x plus 2 on both of them, so I've got x times x plus 2 times 3x plus 1, and that's fully factored. Here it looks like we've got another one with a greatest common factor. I'm seeing 2 powers of t at least in every term, so I factor out t squared, and I'll be left with t squared minus 5t plus 6. That itself is going to be factorable, so I'm going to do that. I'm going to factor two numbers that multiply to positive 6 and add to negative 5. That would be negative 3 and negative 2. So that's going to be fully factored. All right, and number 8, this is one of those that it's quadratic in something besides just x. Okay, so it's got this pattern where it's fourth power, second power, no power, and that is probably just something you're going to want to recognize in this unit. And so when you could either, say, hey, I'm expecting it to be x squared plus a number times x squared plus another number where they multiply to negative 28 and add to 3, but I think that's kind of like too many steps to take in one. So I'll just say recognize the situation, let t equal x squared. That would mean that x to the 4 would equal t to the 2. So I've got t squared plus 3t minus 28, or you could use u or a or whatever letter you like besides x. Okay, and then I know how to factor that. Okay, two numbers that multiply to negative 28 and add to positive 3 would be positive 7 and negative 4. Okay, but we said t was x squared, so it would be x squared plus 7 times x squared minus 4. And x squared minus 4 is the difference of two squares. Okay, x squared plus 7 is not, so I can't do anything with it. And x squared minus 4 would be x plus 2 times x minus 2. Alright, now let's do form B. So x squared minus 2x minus 35. This is one of the old-fashioned ones. So we're looking for two numbers that multiply to negative 35 while adding to negative 2. I'm feeling like that's going to be negative 7 and positive 5. Yeah. And that's as far as I can go, right? I've decomposed it into linear factors, so I'm done. Alright, the second one, this is looking like a difference of two cubes. So I'm going to identify what's my A and what's my B. So 27a to the 3 is the cube of 3a. Okay, so I'll have 3a minus 1 multiplied by, if I square 3a, I'll get 9a squared. A times b would be 3a times 1 plus 1 squared. Okay, that's as far as I can go there. On this one, I'm seeing a greatest common factor, so I'll factor out that x that I'm seeing that's in all three terms first. And then this thing I'm left with is a quadratic, so I should be thinking to myself, hey, is this possibly factorable? And if you take the 3 and the 5 and you multiply them together, you get 15. You think about two numbers, can you think of them that multiply to 15 while adding to negative 16? And I think I can. I think that would be negative 15 and negative 1. So I'm going to factor, or I'm going to not really factor, I'm going to split out that negative 16x to negative 15x and negative 1x. And then I'll do group and factor on this whole thing. I'll need to factor out a negative 1 so that I can get an x minus 5 and actually factor out this binomial from both things here. So I'll have x times x minus 5, and I'll be left with a 3x and a minus 1. And that's fully factored. Alright, this next one, this is with this pattern where it kind of looks quadratic, but it's quadratic in x squared. I like to say maybe I'll use u this time since there's been a lot of t in this quiz. So we'll say u equals x squared, and x to the 4 will equal u to the 2. So this is u squared minus 7u minus 18. So I need to think, are there two factors of a negative 18 that add to negative 7? Yeah, I wasn't seeing it, but, oh, okay, yeah. Negative 9, positive 2. Okay, and then we know that u is x squared, so we've got x squared minus 9 times x squared plus 2. We've got ourselves a difference of squares here, so we'll factor that. No, we won't factor a sum of squares, though, because we don't have anything for that. Alright. You see 4 terms, you should be thinking group and factor. So first check for a greatest common factor. I'm not seeing anything common to all 4 of these, so I'm going to think about the first 2. Y to the 3 and positive 8y to the 2. I see 2 powers of y. And negative 4y and a negative 32, they both are negative. And 32 is divisible by 4, so I can factor out a negative 4. And then again, I'll be left with y plus 8. That's a good sign. So that's y plus 8 multiplied by y squared minus 4, which is a difference of 2 squares. And yeah, that's fully factored. Here we've got a sum of 2 cubes, where the first thing getting cubed is x. The second thing getting cubed is 2. That's not a cube. 2 to the 3, yeah. So since this is x to the third plus 2 to the third, I can factor that with x plus 2 multiplied by x squared, negative 2x, and plus 2 squared. And yeah, that's as far as I can go with that. Right, here we've got 3x to the 3 minus 75x. That's got a greatest common factor. I think, oh, it's the 75 is divisible by 3 because it's 25 times 3, so I can factor out a 3 and 1 power of x. Oh, and that I'm left with a difference of 2 squares. So I can say that's 3x times x plus 5 times x minus 5. Right. Now this last one also has a greatest common factor. It's got at least 3 powers of t in each term, so I'm going to factor out a t cubed. Be left with a t squared, negative 5t, and a negative 6. And then I think to myself, what are 2 numbers that multiply to negative 6 and add to negative 5? I think that would be... Oh, I was thinking 3 and 2, but that's what they want you to think. It's going to be negative 6 and positive 1. Okay. And yeah, that's it.